Hey students, so let's work through the 115, activity 115, practice problems. So if you get stuck, don't copy them directly, but if you get stuck on a problem, hopefully this explanation will help you greatly. So let's switch it over. All right, so this is what we're looking at. All right, okay, so the first thing it wants us to do is sketch and annotate the gear train described above. So if we look here, we have a simple gear train that has 3 gears. So we're going to have 3 circles down here. Gear A is the driver, has 8 teeth, 24 teeth, B, and C has 16 teeth. So if we look at the teeth sizes are going to be the same, size is the same. Because there's more or less of them, then the smallest number is going to be the smallest wheel. So we could go ahead and draw a small gear. B is the largest with 24, so we can draw a larger gear. And then gear C has 16 teeth. It's about double the size of the 8. Okay. So we need to label them. Gear A, all right, is the driver. And we can just say driver. I'm going to get a different pen because that one's been flaky. We'll switch to black. And has 8 teeth, so we can say N equals 8. Gear B has 24 teeth. N equals 24. And gear C has 16 teeth. N equals 16. Okay, so if the output of C, so here's the driver, here's driven. If the output is at C, what is the gear ratio? So we know that our formula for gear ratio equals number of teeth out divided by number of teeth in. So that means my gear ratio, if we substitute in number of teeth out, what's coming out? 16, because it is the one being driven. This is the one that has the motor attached to it. It's the driver. It's the one that's in control. So this is in, this is out. Okay, so out is 16. Number out, 16. Number in, going in, the one that's attached to the motor, the one that's the driver, number in is 8. So that's divided by 8. 16 over 8, we can simplify it 2 over 1. And that leaves me a gear ratio. So gear ratio equals 2 over 1, or that's also equal to 2 colon 1, or 2 to 1. Easy peasy. So if gear A rotates at 60 revolutions per minute, how fast is gear C rotating? So our gear ratio, okay, so we're talking about speed here, all right. We're talking about angular momentum, and that's why we have this little weird W. But the gear ratio is equal to angular momentum in over angular momentum out. Okay, so now we need to substitute and solve. We have to pull information from the prior problem. Okay. So we know the gear ratio is 2 to 1, or 2 over 1. Okay? So we're trying to solve how fast is gear C rotating. So how fast is this one rotating? All right? So what is W? And we said earlier that this is the in and this is the out. All right? Input, output. All right? So this is W out. All right? And we're trying to find that on this previous page. All right, so we're trying to find this W out. So we know the gear ratio, right? We solved for it here. We know it's 2 to 1, all right, or 2 over 1. Okay, it helps, it's my advantage to do the 2 over 1 here. All right, so I want to say 2 over 1. I'm substitute for the gear ratio equals, all right, we know gear A, which is Wn, all right, or angular velocity N, all right, is rotating at 60 revolutions per minute. So I can do 60 RPM, revolutions per minute, and that's going to be over, all right, the angular momentum of C, all right? Or you could think of it as W out, either one, all right? But, all right, this is W out, but it's also the angular momentum of C, all right? So that's where that comes from. All right, so we can say, all right, it's the angular momentum of C. And that's what we are solving for. All right, so if we do our multiplication, all right, we can cross multiply that, and that's going to leave us with, all right, 60 RPM over 2, all right, WC equals 60 revolution per minute divided by 2, so that leaves me a WC is equal to 30 revolutions per minute. Okay. All we did here is basically we multiplied through by WC, right? And we divided by 2 to get rid of the 2 over here. Okay. So we just did algebra. Don't get upset. All right, number 4. If the output of torque at gear C is 150 foot-pounds, what is the input torque at gear A? All right, so again, we're going to use that gear ratio. Gear ratio is equal to torque out over torque in, right? And I just pulled these from my notes, all right? And I'm going to be solving what is the input torque at gear A. All right, so that is torque in or torque at A, however you want to say it. All right, so this is what we're solving for. All right, so when we substitute in gear ratio, all right, we said earlier that that is 2 to 1, and that equals, all right, torque out, all right, and the output is at C. So this is 150 foot-pounds, all right, divided by torque in, all right, in that case, this is torque at A, all right. So what I'm going to do to solve this, and I'll work it through so I don't confuse you, we're going to multiply this times torque at A, we're going to multiply this at times torque at A, all right. When I do that, I'm going to get 2 torque at A is equal to 150 foot-pounds. All right, divide by 2, divide by 2. That cancels. Torque at A is equal to 150 foot-pounds over 2. All right, divide that by 2. Torque at A is equal to 75 foot-pounds, right? Because my units carry. All right, moving on. Compound gear train is composed of 4 gears, A, B, C, and D. Gear A has 10 teeth, is meshed with gear B, okay? Gear B has 20 teeth. So A is about half the size of B. So what I'm going to do is I'm going to say, here is my gear A, all right? And we know it has 10 teeth, so N is equal to 10. And then All right. Gear B has 20 teeth and shares a shaft with gear C, all right, which has 16 teeth. Gear C is meshed with gear D. All right, so as we do this, all right, so we have B and C together. A and B are meshed together. C and D is meshed together. So we can draw that, all right, so they are together. So B and C are together. I'm going to draw, and we're going to, I'm going to go ahead and draw D, all right, so I don't have any overlapping because I'm using a pen. All right, it's way easier. All right, so here's D. All right, D is unknown. Okay, what we don't know what the number is. Okay, because A has 10 teeth, gear B has 20 teeth, and shares a shaft with gear C, which has 16 teeth. All right, so we have B. It's sitting somewhere here. And then we have C that's attached to it. So this is B, and this is C, and this N equals 20 on this B, and N equals 16 on this C. So you have something that looks kind of like that. Okay. It's probably easier to do it with a pencil, if I have a pencil here. Okay. Let's do that again where it's not quite so confusing, because I think I probably confused you a little bit. All right, so gear A has 10 teeth, so I'm going to draw 1. N equals 10. All right, and this is gear A. All right, it's meshed with gear B that has 20 teeth, so it's going to be about twice the size. All right, so here's B. All right, the number equals 20. Okay. It shares a shaft with gear C, so it's got to have the same center point. All right. Shaft C has 16 teeth, so I can draw it here. So it's got the same center point. All right, and this is C, and N equals 16. All right, and then C is meshed with D, so those have to be touching. All right, so something like that. All right, and this is the part where your eraser comes in handy, so you can erase that. All right, and this is D. All right, we don't have any more information on that. So that's kind of how you put that together. It's better to use pencil so you can erase. Okay. The necessary torque output for the system is 500 foot-pounds. What should the gear ratio of the system be? Okay, so we're talking torque. So we can look in our engineering notebook. Gear ratio is equal to torque out divided by torque in. Okay, same formula we used a while back. All right, gear ratio. So we're going to substitute and solve gear ratio. All right, because that's what we're asking for, gear ratio. Okay, torque going out needs to be 500 pounds. That's where that number comes from. So torque out is 500 foot-pound divided by torque in. And if we look at our paper here, power is supplied at gear A with 100 foot-pounds of torque. So this is 100 foot-pounds of torque. Foot-pound divided by foot-pound cancels. It leaves me a unitless number, which is the gear ratio, is equal to 5/1, or 5-1. Okay. With a system torque output of 500 foot-pounds, how many teeth should gear D have? So we're going to look back here, all right? So if I have a system output, all right, I'm putting in 100 foot-pounds, all right, and I'm getting out 500 foot-pounds. N equals what? All right, so how many teeth? What's the size? How many teeth do I need to get 500 foot-pounds coming out? Okay, and then of all of the questions in this worksheet, this is the hardest one. Okay, but we can do it. Okay, so let's go to our formula. All right, we need number out. So we have gear ratio equals number out over number in. All right, and we have to know that we multiply when we have a compound gear set, when we have more than one gear together, right? One that shares a axle, right? We can treat those as two separate gears, okay? And we multiply them together to solve that, all right? So that's the hardest part, is you have to remember that from your notes, and that's in your notes, okay? So when you do compound gears, you're going to multiply them together, all right? So our gear ratio, so we need to figure out this side. Our gear ratio is actually going to be two sets of numbers, okay? Because we're going to use the number of teeth, okay? So when we look at gear A to gear B, all right, so we have gear A to gear B, and we have gear C to gear D, all right, the two that are intermeshed, all right, so we need to multiply gear A, the gear ratio of gear A to B, at times the gear ratio of C to D, because we have this compound gear. Okay, so if we look at the number of teeth, it's in out divided by in. All right, coming out of A and B is 20, going into A is 10. Okay, so I'm going to have 20 over 10. All right, and that's going to be multiplied, because that's what you do according to our notes. All right, so number of teeth out divided by number of teeth in. Here's where this came from. All right, I've got two compound gears. I've got the number out on the A to B, 20, number in, 10. So now for the second one, all right, what's going in, because these turn together, so this one is the driver if we're looking just at C and D. All right, so number in is 16. Number out is some unknown number. All right, so we're going to say that is in D, number at D. So number out at D, number out at D, divided by number in at C, which is 16. All right, then I suddenly have a super easy problem to solve. Right? I can solve this equation. All right, and that gives me, all right, if I go and do all the math, and I'm not going to do the algebra one for you, but if I do all the math, I get ND, all right, divided by 8. All right, time you simplify and multiply everything. All right, and ND divided by 8 will then simplify, all right, to 5 over 1. All right. And then if we cross multiply, all right, we're going to get the ND is equal to 40 teeth. All right, 40 teeth. All right. So again, it's just cross multiplication. We get the 40 teeth. All right, n times 0, 8 times 5. And that's the hardest one, because you have to remember these are on the same axle. Okay. All right. In a pulley system, pulley A is moving at 1500 RPM and has a diameter of 15. All right, so pulley A, diameter 15 inches. All right. Then I have three pulleys, A, B, and C. All right, it says they're all different sizes. I can make this up to anything I want, but I'll do 3 pulleys here. Okay, and I have B, C, and D. All right, and it's a pulley. I'll have it connect to B. All right, at the center point, they rotate together, they turn the same direction. Okay. Oh, and the other thing is this is 1500 RPM. All right. So speed of 1750. Oops. 1750 is required when the drive bell is connected to pulley B. What is the diameter of pulley B? All right. So we're talking about diameter and we're talking about angular velocity. So we can pull from our notes those two items and we know they are equal. D out, diameter out, divided by diameter in, and I'm just pulling this from my engineering notebook. We said all these were equal, okay? So angular velocity in over angular velocity out. Remember, angular velocity is the one that's reversed. All right, now we just have to substitute and solve, okay? So the diameter, so I'm looking for the diameter of B, so diameter of B, all right? That's the output gear, right? This is A is going to be your input, divided by diameter, 15 inches. That's my input, right? So this is in, this is out, right? Depending on which pulley that you do. And this is very common in engineering, all right? So dB divided by 15, okay? That equals, and we can do the angular velocity in. All right, so the angular velocity going in is this 1500 RPM. Divided by the we want 1750 revolutions per minute. 1750 RPM. All right. And then that leads us to, all right, dB, all right, 15 inches times 1500 RPM over 1750 RPM. All right. RPMs cancel. 15 times 1500 divided by 1750. You put that into your calculator. The diameter of B is going to be equal to 12.9. What unit do I have left over? Inches. Okay. The rest of these problems, 10 and 11, all right, are exactly the same. Okay, you're going to go D out over D in equals angular velocity in over angular velocity out. You're going to do DC over 15 inches equals 1500 RPM over 2000. You're just changing it to a different one. 2000 RPM. All right, and then that's going to leave you to diameter C is equal to 15 inches times 1500 RPM over 2000 RPM. That's going to leave you 11.3 inches. Same deal here. All right, exactly the same. I'm not going to work this one out. You're still going to use the D out over D in is equal to angular velocity in over angular velocity out. All right, you do all this exactly the same as before. You get 6.92 inches. All right. Last two things. The industrial overhead door has a sprocket and chain system designed to reduce the force needed by an operator. To open and close the door, the system consists of two individual systems that are connected through a live axle shaft. Here's my live axle shaft. To operate the door, the operator pulls a continuous loop of chain over a fixed 22-tooth sprocket. All right, so here's my sprocket, and there's a loop of chain. All right, and this has little teeth all the way around. All right, N is equal to 22 teeth. All right, the second 22 sprocket is attached to the live axle shaft and uses a chain connected to a 48 tooth sprocket that is attached to a drum that drives the door. All right, so we get a 48 tooth sprocket, so this is going to be big, 48 toothed. All right, and this drives the pulley. Okay, so our sketch looks something like this. We have a 22 tooth sprocket and a 48 tooth sprocket. All right, so again, this is the sprocket. Looks like the one on your bicycle. All right, so it's not smooth. So it looks something like that. What's the overall system gear ratio? So our gear ratio, we're talking the number of teeth, so number of out over number in. All right, so that leaves us to substitute and solve from there. So gear ratio is going to be 48, number out. All right, so here's where you are putting the effort in. All right, I'm going to yank on this chain, and it's going to roll up the door, and this is where the effort's coming out. All right, out. Okay, so now, all right, number out coming out is 48 teeth divided by number in, which is 22 teeth. All right, 48 divided by 22 gives you 22.18 over 1, or that equals 2.18 to 1. And that's it. That's the whole kit and caboodle. All right, thanks guys.